Hey, hi everyone. For those of you watching later, I'm just going to wait a couple minutes for anybody to join live that wants to. So I'll go on mute for a couple minutes and then come back and start answering the questions. Okay, so I'll go ahead and get started with the questions on Piazza. For those of you that are watching live, feel free to update the Piazza thread with any additional questions that you guys might have. Okay, so our first question, I'm still having a difficult time wrapping my head around how to implement the spanning tree protocol. One question I can't seem to figure out is how does a node determine its distance from the root? In the lectures, the professor makes a statement. He says, when neighboring nodes receive an update, they determine their distance to the new root by simply adding 1 to any message they receive. I'm not quite sure what this really entails. What part of the message are they adding 1 to? How would this help them determine the distance to the root? So I think David's follow-up is pretty good, but I'll go ahead and kind of walk through that. So the first part of the spanning tree protocol, everybody claims their root. And like in David's square topology, all the nodes 1, 2, 3, and 4, they would all send out an initial message to all of their neighbors saying that I'm the root and my distance to root is 0. And that's the first step in the topology. So all of the switches at that point would, if they're receiving a message from a neighbor with a lower switch ID, then they update their view of root, and their distance to root is now 1. And so then once that update has been made, they need to send out an update to all of their neighbors to say that we have a new perspective on root. So instead of this message saying that their root is distance 0 to root, they'll send out the message with the distance 1. And then when the neighboring switches receive that message, they'll add 1 to that one. So then the neighbor will now view their distance to root is 2. So in the code that's provided for you guys, the message object has a distance parameter that will have this variable. So it won't always be 1. You'll need to check what the message distance is when you receive a message in the process message function, and then you'll add 1 to that to see your actual distance to root. Okay, and then as a follow-up to that one, it says, but would we need to keep track of which links have the shortest distance so we can disable links that are not on the shortest path or paths that other switches are using? That is where I'm having trouble understanding. And then it goes on to talk about switch 4, understanding that the following path 1, 2, and then 2, 4 is 2 hops away. And then it says that it will send 3 a message saying that the root is 1, so 3 will update its view of the root to 1, and the distance to the root to 3. Actually, like in our simulation, for the square topology in particular, in the beginning, everybody sends like their neighbors the message saying that they're root. So in this case, 3 would already have received the message from 1 saying that I'm root with a distance of 0. So when 3 receives the message from 2 saying that 1 is root, it would ignore that because it would say that's a longer path. So I shouldn't update that in my data structure. But in the case that you have received like a shorter path to root, then you would just need to deactivate your longer path to root in your links or whatever your data structure is that you've defined. And then And then at the end it says, I also understand that if the path 3-4 was to be used by other switches to reach root, then it would not be closed. So yeah, that's true. Like one thing you might want to track is if the path through for a particular link was set to true, and that might influence what you disable when you find a shorter path to root. Okay, and the next question, when generating the log string, should the links for a given switch be ordered? For example, 2123 or 2321. And no, this one does not matter. We used to have that as a requirement, so there might be a couple comments in the switch.py that are a little bit confusing and kind of allude to this. I thought I'd remove those, but we removed that requirement because it's a little bit arbitrary and it just ends up making things complicated when students miss that and we get a bunch of regrade requests. So no, your order does not matter anymore. Okay, and the next question, along the lines of generating the log string, I'm having difficulty figuring out how to format it exactly as specified. I can do so if I use if statements, if there are more than one connection format this way, switch link, switch-link, but I only have this for 2 active links. I could just add more if statements, but I assume there's a better way to do this, like a for loop. However, I cannot figure out how to get the comma in the next iteration on the same line as the first connection. So yeah, I think Ty had a comment about using the for loop, and that's definitely the route that you want to go. There's really no telling in like the evaluation topologies how many active links there might be for a switch, so you don't want to rely on like having a certain number of if statements that will add only a certain number of links. So typically what you would want to do is define like an empty string and then have a for loop statement that kind of loops through your links data structure, whatever you've defined to keep your active links in, and then it appends them one by one, and then it also appends a comma each time. And then like Ty said, you can use this format or some other format to kind of split off the trailing comma. Okay, and then the next question, how is the exam going to look? How long will the exam be? How many questions? Is there anything prohibited during the exam? Okay, so I haven't seen the final copy of this semester's exam, so I can't really say for sure. We'll post some more information this week once I discuss this with Dr. Conte, but historically, and I believe this will be the same for this semester, you'll have 2 hours to complete the exam, but we estimate it should not take you any longer than an hour. So the extra hour is kind of to account for if you have any issues with your internet or any issues with ProctorTrack, you won't feel rushed if you have to spend some time getting those resolved. How many questions? It's normally around 20 questions, but that can kind of fluctuate. And is there anything prohibited during the exam? So it's going to be a closed book, closed notes exam, so you can't have anything open on your computer. We'll be using the ProctorTrack software, which I'll go into a little detail in one of the later questions, but basically all you're allowed to have open is the test screen on your computer, and everything else is prohibited. And also make sure no headphones and typically no scratch paper is allowed for the exams. Which, as far as scratch paper, we're not going to give you any questions that would require you to need that, so don't worry about that part. Okay, so the next question, can you give some use cases on how to best use path through or deactivate links. Okay, a little bit in the last week's office hours and gave an example. So one example would be like in the sample PY that's provided when you have like the 1, 2, and 3 in a line, and 3 is downstream from 2. Typically, 2 would want to deactivate the link to 3 because it doesn't need to go to 3 to get to the root of 1, which is its upstream neighbor. But 3 needs to make sure that 2 keeps that link activated because 3 needs to go through that link to get to 1. So in that case, the switch 3 would send a message with a path through set to true to switch 2, and then switch 2 would process that message, and since the path through was set to true, it would leave that link activated. As far as deactivating links, typically, like when you want to deactivate links, there's a good discussion on the Piazza post that's linked in the follow-up comment. But when you want to deactivate links, this would be something like you found a shorter path to root, so you need to deactivate what it's tracked as its current short path to root. So just basically all you have to do is remove that from your data structure, or depending on how you set it up, you could, if you're tracking all of the links from the switch, just change the, like, I guess, activation true or false. You can set it's active to false if you're tracking everything. Otherwise, just remove it from your dictionary or list. So hopefully that answers your question, and that's the type of use case you're looking for. Okay, and the next question, do we actually need to track the blocked links for project 2? I realize that not using them is more of a brute force approach, but I didn't see anything indicating such a grouping must be used or would be evaluated. So the answer to this one is technically no, you don't need to track the blocked links. You can if you want to. It's really up to how you do your implementation. The only output that we're going to be checking for is to make sure that your spanning tree in the output file is correct and all the links are correct. So that would just be your active links. Technically, since you have the self.links parameter that have all of your neighbors, and then you have your data structure to track the active links, anything that's in self.links but not in your active links data structure would be a blocked link. So you don't necessarily have to track those individually. Okay, next question is about the test prep questions. For question 6, layer 2 switches will have a forwarding table as opposed to a host style ARP table, right? So the entries in this table will be port to MAC address rather than MAC address to IP address in an ARP style format. I didn't see any mention of this in the videos, so I was wondering. And yes, that's correct. You'll have a table with like the destination MAC address and the out port instead of having the IP address. So I'll post the test prep solutions this weekend and you'll see the answer to that, but that's what your table will look like. Okay, next question is, for me, this would be the first time taking an exam. I'm looking for details such as where do I register for the exam, what I need to request for a proctor, etc. Any document that describes the process would be helpful. Okay, so like I mentioned before, we're using the ProctorTrack software. So there's nothing that you guys need to register for. I'm following up on this one. If you haven't already received an email from another class registering you for the ProctorTrack software, you should be receiving one soon. That will come to like your GA Tech email or whatever it's forwarded to. So that'll give you a link to sign in, and the first time you sign in, it'll just be your regular login. And I think you have to click forget password and set up a new password. If you've never taken an exam through ProctorTrack, you should be receiving an email soon registering you. I'm looking into how to get everybody set up. So there's nothing that you need to do until you receive the email. Would I need to request a proctor? No. For this one, ProctorTrack is really nice in this aspect. Whenever you're ready to take a test, you just log in and click start the process. And basically what happens is it downloads the software onto your computer, and then it relies on you having a webcam and a microphone available. And it records you as you're taking a test, but there's not a real live proctor, so you can do it whenever you want to. So some things to expect when you first download the software: it makes sure that you don't have any unauthorized programs running on your computer. So like no word processors, basically nothing but the browser that you're using to log into the ProctorTrack site. And then first it'll do a check to make sure you don't have any extra monitors plugged into your computer, that sort of thing. Only one keyboard and mouse. And it makes sure that you have a webcam and a microphone available. And then it'll do a couple of identity verification checks. It will ask you to scan your knuckles and scan some form of government issued ID. And then it'll do a facial scan. And then it will take you into the exam from there, where you'll load the different questions in ProctorTrack, and you'll go through one at a time, and you can come back to any that you haven't answered, so it's fine to skip around on the questions. And if you have any issues during your test, the ProctorTrack support can help you. There might be a couple times, it's rare, but it does happen, that you get booted out of the test, and you might have to contact the instructors to reset it for you. So in that case, just send us a private message on Piazza, but typically the ProctorTrack support can help you with any issues that you have while you're taking the test. Okay, so the next question is, it is supposed to build a data structure for each switch to store the corresponding state. If so, what is the initial state with root claim itself? And that's referring to the to-do from the switch.py that says define a data structure to keep track of which links are not part of the spanning tree. So yeah, when you define your data structure in the init, you'll define it as a class variable, or an instance variable. So each time you have an instance of the switch.py, it will have its own data structure. And that as long as you use like the self dot and then the name of your object, it'll be accessible in all the other messages. All the other functions that you're using in that instance of switch.py. So each switch will have one, and with the spirit of the project, you're not allowed to access this from any other switch. And as far as the initial state, typically you can start with a root claim of yourself as your self switch ID. As far as the active links, you probably want to have these empty and then update them as you're processing the initial messages. And then you can start defining them. So basically it's just setting up the structure in the init method. You can set the distance to root as like some negative number or 0, however you want to handle that for updates later. And then each time in the process message, you'll kind of fill this one out and update it as you go along. And log string can be generated from this data structure with the active link inside. Yes, that's how you're supposed to generate your log string. So it should be completely based on your data structure that you put together in the process message. Any kind of like global variables or implementations that are not based on updating the data structure from processing the messages, those are not considered the distributed algorithm that we're looking for. So if we find that's how your program is coded, you won't get full credit for that. Okay, so next question. Are we allowed to create our own functions in the project? For example, we have to send updates to neighbor nodes many times. It would be easier to write a function method to do that. Is it okay in the project? And yes, that's fine. You can create as many helper functions as you want. Just make sure you're not relying on any global variables, but helper functions are totally fine. And the second part of this question, so far, Professor Conte has only had one office hours. When is the next one, and when is the first discussion post going to be posted? This one, I think maybe since it was a holiday week this week, she did not have an office hours. I will check with her on the first discussion post. Typically, she's the one that posts those herself, so I'm not sure what her plans are regarding that one, but I will try to find out for you guys. And then the third part of this one, also in P2, I seem to have a gazillion if statements. Is that expected? There's some implementations I've seen of Switch PY. They're really straightforward, and they don't have a lot of if statements. That's typically expected from some of the more experienced Python coders. If you're not experienced in Python, it's totally fine to have a bunch of if statements or a less clean solution. As long as it works, it doesn't have to be perfect. Okay, so let me refresh and see if there's any extra questions. Okay, I don't see any other unresolved follow-ups that I haven't addressed in Piazza at the moment. If you have any additional questions on something I've answered that might not have been clear, please post that. Or any new follow-up questions, please post on Piazza. I'll continue monitoring and see if there's any more showing up. Okay, so one follow-up question about the data structure. It says data structure is supposed to set as empty before receiving the root claim from neighbor. If so, any possibility to receive any other message before these root claims? So no, the way it's set up, the first method that's called will be your send initial messages. So all of your initial messages from all of your switches will be kind of put into a queue to be processed. And these will be your first messages that will be processed before any of the follow-up messages will be added to the queue and kind of processed after all of those are finished. So you can be guaranteed that all of the initial messages will be processed first. So this will be all of your messages with the claiming root as its self and the distance is 0. Okay, so I'll hang out for about 5 more minutes. If anybody has any additional questions, go ahead and post. Otherwise, we can go ahead and hang up, and I'll let you guys get back to your Thursday evening. Okay, so I'll give it 1 or 2 more minutes for any last minute questions, and then go ahead and drop off. Okay, I don't see any new questions, so thank you guys for joining. And if you need any help for Project 2, we have a couple of TA chat sessions, one tomorrow at 9:30 a.m. Eastern Time, and then one on Saturday at 4 p.m. Eastern Time. And feel free to post any questions you might have on Piazza in the meantime. So thanks for watching, and I'll see you guys again next week.